My dear students, welcome to Easy BTech, your guide for BTech and beyond. And we are discussing subject signals and systems. And topic is today's topic. We are going to see problems on Laplace transform. So very important session. Let's start our session problems. The first problem, Laplace transform of, find Laplace transform of e power minus at sine omega naught t u of t. And another one, e power minus at cos omega naught t u of t. And e power plus at sine omega naught t u of t. E power plus at, e power plus at cos omega naught t u of t. So the thing is very simple to do. So we know Laplace transform of u of t. This we know. What is the Laplace transform? 1 by s. If you multiply this by e power minus at, if you multiply this by minus at, then it will become 1 by s plus a. 1 by s plus a. And here ROC, u of t ROC, real part of s is greater than 0. After multiplying by e power minus at, the ROC will become real part of s is greater than minus a. Real part of s is greater than minus a. Right? The same effects, the same thing we are going to apply here. First, sine omega naught t u of t, this Laplace transform we know. So first consider this Laplace transform of sine omega naught t u of t. What is the Laplace of this sine function? Laplace omega naught by s square plus omega naught square. And ROC, real part of s is greater than 0, right? As like u of t. Now this multiplied by e power minus at means wherever you have s, it will replaced by s plus a. That is the meaning, right or not? Here u of t 1 by s, e power minus at u of t is becoming 1 by s plus a. So s is becoming s plus a. So the same concept here also, e power minus at sine omega naught t u of t. So what will be the answer now? Laplace of this omega naught by s is becoming s plus a. So s plus a whole square, s square is there, now it will become s plus a whole square omega naught square. And what about ROC here? So in the previously ROC is greater than minus a. So here also multiplied by e power minus at, that is why real part of s is greater than minus a. ROC. Very simple, right? Similarly, the second one also we can do. Second one is the cos omega naught t of t. So already we know the second one I am doing here. Laplace transform of cos omega naught t u of t. This we know. Cos omega naught t u of t. What is the answer? S by s square plus omega naught square. And ROC is real part of s is greater than 0. Now we want Laplace transform of e power minus at cos omega naught t u of t. So what will be the answer? You can tell now. Whenever you are multiplying the signal by e power minus at, s will become s plus a. So here s is there, so s plus a divided by s plus a whole square plus omega naught square and ROC changes. What is the ROC? Real part of S is greater than minus A. Okay, right or not? Next thing, e power at sin omega naught t, e power at cos omega naught t. Same way like e power minus at sin omega naught t. So S will become S minus A if you multiply by e power at. So S is becoming S minus A, right? Okay, let's have these two. So we know Laplace transform of u of t. What is this? U of t Laplace transform 1 by S, and ROC also we know real part of S is greater than 0. Now this u of t is multiplied by e power at plus at. So what is the e power at u of t Laplace transform? 1 by S minus A. So S is becoming S minus A, right or not? And ROC is real part of S is greater than A. Real part of S is greater than A. Right? The same concept we are going to apply. This e power at sin omega naught t u of t. So first we write Laplace of sin omega naught t u of t. What is the sin omega naught t u of t Laplace transform? Omega naught by S square plus omega naught square, and ROC is real part of S is greater than 0. Greater than 0. Now this is multiplied by e power at. So e power at sin omega naught t u of t. What happens to this? So omega naught by S minus A. S is replaced by S minus A whole square omega naught square, and ROC is real part of S is greater than A. That's all. And similarly cos. So first for cos function we need to write Laplace transform, then we go for e power at cos function. So Laplace transform of cos omega naught t u of t, its Laplace transform is S by S square plus omega naught square, and ROC is real part of S is greater than 0. This is the ROC. Now by seeing that cos function we can write e power at cos. So e power at cos omega naught t u of t. So what we have to do, S is replaced by S minus A. That is the logic. So S minus A by S minus A whole square plus omega naught square. So here real part of S is ROC. If you come to ROC, real part of S is greater than A. Right? Next thing, just in the previous session already we have done t u of t Laplace transform. Suppose I want t square u of t Laplace transform. So how to do it? Now we know that differentiation in S domain, we know that Laplace transform of t into x of t or minus t into x of t. This will be d by ds of x of s. So x of s is differentiated with respect to s one time, 1 minus t multiplied, 1 time minus t multiplied. So in the place of x of t, I am going to take u of t. So what is Laplace transform of u of t? 1 by s. So which will be x of s. This is x of t. Right? Now we are multiplying our x of t by minus t. So then d by ds of 1 by s. So right side 1 by x, it is like d by dx of 1 by x minus 1 by s square. So both sides we can cancel minus. So t u of t Laplace transform is 1 by s square. Right? 1 by s square. Now we want t square u of t. Means you are multiplying again by t. Right? So we are multiplying again by t. Then it will become t square u of t. So as per, if you multiply one time t, we need to do differentiation of x of s one time with minus t. So here one more time is multiplying. So how to write it? How to write it? How to do it? How to do this now? So very simple. Again we need to do differentiation of this 1 by s square one time dy ds of, okay. So simple, this will be obtained as, so I am taking here minus t. With minus only we need to do differentiation with minus, then d by ds is right side. So minus t, again t into u of t is equal to d by ds of 1 by s square, d by ds of 1 by s square. So this simply we can do differentiation d by ds of s power minus 2, right? So what is our d by dx of x power n into x power n minus 1? That's all. So here minus 2. So minus 2 into s power minus 2 minus 1, right? So this will become minus 2 by s cube, minus 2 by s cube. So this is left side what we have, minus t, again t u of t. So both sides we can cancel minus sign, then it will become t square u of t is equal to 2 by s cube. So this 2 I can write as 2 factorial divided by 2 factorial is 2 only, s power 2 plus 1. We can write like this, right or not? Both are same. Now similarly, so what we got first, t u of t 1 by s square, this we can write as 1 factorial by s power 1 plus 1 we can write, and t square u of t Laplace transform is, now it is t square. So what we have, 2 by s cube, we can write it as 2 factorial by s power 2 plus 1. So similarly, t power n u of t, power n u of t. So how to do Laplace transform of t power n u of t? Same here, n factorial by, okay, n factorial by s power n plus 1. This is the way. So here 2 factorial means you can write as 2 into 1, right? Here n, so n factorial, okay. So this is a way of doing to t power n u of t Laplace transform. T power n u of t Laplace transform is n factorial by s power n plus 1, s power n plus 1. So here I will tell one more problem. Laplace transform of e power minus a t u of t is 1 by s plus a. Then Laplace transform of t into e power minus a t u of t. How to get it? What is the Laplace transform of t into e power minus a t u of t? How to do? Differentiation property, differentiation in s domain, just we can do easily. So we know that Laplace transform of minus t x of t is equal to d by ds of x of s. So here e power minus a t u of t is a x of t. So Laplace transform of e power minus a t u of t e power minus at u of t. This will be 1 by s plus a. Already we know it. Now we want minus t here. Minus t e power or x of t. Minus t into x of t. That means e power minus at u of t. So how to get it? By doing differentiation of 1 by s plus a. Right or not? That is the property we have. Same we are following. So differentiation of 1 by x minus 1 by x square. So minus 1 by s plus a whole square. Now here minus minus we can cancel. Then Laplace transform of t e power minus at u of t. It will become 1 by s plus a whole square. Okay, 1 by s plus a whole square. Clear? So we can do problems easily by using properties. That is the point. And we can do initial and final value. So find initial and final value. Initial and final value of given. The first one 1 by x of s is equal to 1 by s minus 2. And the second one 1 s minus 1 by s into s plus 1. And the third one 1 by s square plus 4. So here I want to mention one point about final value. So final value theorem is not applicable. Final value theorem is not applicable. Not applicable if poles are on imaginary axis. On imaginary axis. So pole means denominator roots. So here s minus 2, what is the root? S equal to 2. It is on right half of s plane. Okay, so final value theorem we can apply. Here s is equal to 0 and s is equal to minus 1. We can apply final value theorem. Here s square plus 4. Poles I am writing. S square is equal to minus 4. So s will become plus or minus 2j. Plus 2j minus 2j. So we are getting poles on imaginary axis. Plus 2j minus 2j. So in this case, final value theorem not possible or not applicable. So for the third one, final value theorem not applicable. Okay. So whenever you have poles on imaginary axis, final value theorem is not applicable. Right. Next, we follow now solution. We will see solution now. First one, initial value, final value. What is the initial value? How to do initial value? Initial value means x of 0 is equal to limit s tends to infinite s into x of s. S into x of s. This is equal to first problem. Limit s tends to infinity s into x of s is s minus 2. Okay. So in the numerator and denominator, take s common. Already s is there in the numerator. In the denominator I am taking s common. Then 1 minus 2 by s. Limit s tends to infinity. So then apply the limit infinity by 1 minus 0. So we are getting initial value infinity. And final value x of infinity is equal to final value x of infinity is equal to limit s tends to 0 s into x of s, which is equal to limit s tends to 0 s into x of s is 1 by s minus 2, so 1 by s minus 2. So you can put the limit 0 by 0 minus 2, which is equal to 0. So final value is 0, initial value is infinity. That is the first problem. And similarly we can do second problem. S minus 1 by, this is the x of s. Take the given is x of s, because in the formula we have x of s. So x of s is s minus 1 by s into s plus 1. Initial value, how to do initial value? The formula x of 0 is equal to limit s tends to infinite s into x of s. So take x of s, limit s tends to infinite s into x of s is s minus 1 by s into s plus 1. Here ss get cancelled. Then we can take s common from numerator and denominator, because if you apply directly limit it will become infinity by infinity. So in that situations, take s is common. After that keep limit infinity. So if you take s is common, 1 minus 1 by s divided by, here also s is common, 1 plus 1 by s. Then apply the limit, here ss get cancelled, apply the limit 1 minus 1 by infinity is 0, here also 1 plus 0, so answer is 1. So initial value is 1. Next, final value. The final value, how to do final value? X of infinity is equal to limit s tends to 0 s into x of s. So here limit s tends to 0 s into, what is x of s he given? What is x of s? S minus 1 by s into s plus 1. S minus 1 by s into s plus 1. S get cancelled. If you can apply the limit 0, so 0 minus 1 by 0 plus 1, which will be minus 1. Next, third problem. So what is the third problem he given? 1 by s square plus 4. So take the given problem as x of s, 1 by s square plus 4. So final value theorem is not applicable, because final value not applicable because poles are on imaginary axis. Poles are on imaginary axis. Now initial value, the formula is x of 0 is equal to limit s tends to infinite s into x of s. Okay, so substitute x of s, limit s tends to infinite s into, what is x of s? 1 by s square plus 4. 1 by s square plus 4. So here if you apply limit s tends to infinity, infinity by infinity, undefined. So what do you do? Common from the denominator, s square is common. So s by s square is common. Then 1 plus 4 by s square. So here one s is cancelled. Then limit s tends to infinity, s tends to infinite, 1 by here s square is common, right? So 1 by s, 1 plus 4 by s square. Now we can apply the limit s tends to infinity, because there is no 0 by 0 or infinity by infinity, 0 into infinity. That problem is not here now. So 1 by infinity, 1 plus 4 by infinity. So 1 by infinity into 1 plus 0. So we are getting 1 by infinity, which is equal to 0. This is the initial value. Okay. And some more problems we can do based on this initial value and final value. Let's consider x of s equal to s plus 5 divided by s square plus 3s plus 2. S square plus 3s plus 2. So how to do this initial value, final value? So initial value we can do x of 0 is equal to limit s tends to infinite s into x of s. Substitute x of s, limit s tends to infinite s into what is x of s? S plus 5 divided by s square plus 3s plus 2. Okay. Now, if you directly apply infinity by infinity, which is undefined, so from numerator s common, s into s square, 1 plus 5 by s, denominator also s square common, 1 plus 3 by s plus 2 by s square. This total we have to apply limit s tends to infinity. So here s square cancel. By applying s tends to infinity, 1 plus 0 by 1 plus 0 plus 0. So which will be 1. And final value, so how to do final value? X of infinity is equal to limit s tends to 0 s into x of s. So as it is, we are writing x of s into what is x of s? S plus 5 by s square plus 3s plus 2. Okay, now directly we can apply the limit s is 0 because there is no 0 by 0 or 0 into infinity. That situation is not here. So 0 plus 5 by 0 plus 0 plus 2. So 0 plus 5 into 0 is 0 by 2, 0 by 2 is 0. This is the final value of the signal. Okay. So thank you students. Please watch videos regularly. Thank you.